For years, the economics of humanoid robots never made sense. Until this one. Foxconn, the company that assembles your iPhone by squeezing every cent out of labor costs, is buying it. And the reason it works is not what the headlines told you. It is calculation that decides when your job gets replaced or doesn't. I went into their financials. What I found changes the math on everything. The robot is Walker S2, made by Shenzhen-based UBTech Robotics. First question any factory manager asks: can it survive the floor? It stands human height, weighs 70 kilos, built to fit existing aisles and workstations. No factory retrofits required. Load capacity 7.5 kilos per arm, roughly 15 kilos combined. That number is deliberate. The US Occupational Safety Institute sets the safety repetitive lifting limit for human workers at 11 to 16 kilos. UBTech's engineers designed directly to that ceiling. Now, battery life: 2 hours per charge, compared to Tesla's Optimus claiming 8 hours. That sounds disqualifying. But here's what most people miss on the specs. Walker S2 supports autonomous hot swapping. Paired with an on-floor battery station, it swaps its own battery and keeps going. No human required. This function changes everything. A human works 8 hours. The machine works 24 hours, 365 days. No holidays, no sick leaves. Even at 30% efficiency, the robot's worst case, 30% of 24 hours is 7.2 human equivalent hours of the daily output. And now you are probably asking the same question I was. If this machine is that compelling, why doesn't UBTech just publish the price? I went to UBTech's website. No pricing, just an inquiry button. Check their press releases, investor materials, nothing. Then I found a Chinese language interview, barely circulated in English. Base price, 299,000 RMB, about $41,000. That's already lower than I expected. But when I opened the actual earnings report, 2025 revenue from full-size humanoid robots, $170 million. Units sold, 1,079. Divide these two numbers. The real-world average selling price is roughly 105,000, 2.5 times the base price. The difference? Integration services, software, battery station infrastructure, support contracts. You're not buying a robot, you're buying a system. One more thing before we run the math, and I want to be straight with you here. UBTech officially admits Walker S2 is good at stacking boxes, quality inspection, repetitive pick-and-place in structured environment, but it still struggles with precision connector assembly, soft or irregular materials, real-time improvisation, not ready for everything else. Keep that in mind. So, now you know what it can do and what it can't. But none of that matters until you answer the one question every factory owner asks before signing a check. That this machine generates more profit than a human worker. $105,000 all in. Now, let's put that next to the cost of a human. China first. A standard automotive factory worker costs the company roughly $15,000 per year. Wages, social insurance, bonuses, all included. Think of it as one robot equals 7 years of a Chinese worker's total cost to the company. United States? Same math, very different number. A fully loaded American manufacturing worker runs approximately $100,000 per year. Wages plus benefits annualized. Now, let's run the comparison. And I'm going to use the robot's worst case number. 30% efficiency, 7.2 human equivalent hours of output every single day. In China, $105,000 robot versus $15,000 a year worker. Best case, no maintenance costs at all. You are still looking at a 7-year payback period. Factoring real operating expenses, the math just doesn't close. Not yet. The Chinese factories buying Walker S2 today aren't doing it because it pencils out this quarter. They're buying their seat at a table they know is coming. In the US, same robot, same $105,000. Now you're comparing against $100,000 per year worker. Year 1, robot costs $105,000, worker costs $100,000. That's basically a coin flip. And from year 2 onward, the robot works for free. Remember, that's the worst case efficiency scenario. Now, here's where the long game gets interesting. Every year, human workers' wage goes up.
Consumer confidence is surging, blue-collar wages are rising rapidly.
Inflation, labor market pressure, quote 3 to 4% annually. The 100,000 worker becomes 104,000, then $108,000. It compounds, and it only moves in one direction. The robot doesn't get a cost of living adjustment. In fact, it will get cheaper. Here's the number from UBTech's own financials that shocked me. UBTech's overall gross margin jumped from 28.7% to 37.7% in 2025, with humanoid robots flagged as their highest margin product line. Factoring their revenue mix, and the robots themselves are likely running close to 50% margin, and that's before mass production drives costs down further. Which means, in the competitive market, there's enormous room to drop. UBTech's own internal projection, by 2027, the manufacturing cost per unit could fall below $20,000. Picture two lines on a graph. One climbs steadily upward, that's the cost of human labor. The other slopes downward, that's the cost of robot. Somewhere on that graph, those two lines cross. In the US, that crossover has already happened. In China, it's a matter of when, not if. And that inevitable crossover brings us to the question I know has been sitting in the back of your head watching this entire video. What does any of this mean for the people whose jobs these machines are built to replace? 3 categories, honest assessment of each. Category 1, most at risk. Repetitive, high volume, low skill roles in high wage countries. If you are performing the same physical motion hundreds of times a day in a structured environment, and your employer is paying over $40 an hour for it, the ROI math is actively working against you. Oxford Economics projects 20 million manufacturing jobs globally displaced by robotics by 2030. But this isn't a cliff, it's a slope. 5 to 10 years of gradual substitution, starting with the highest cost labor market first. Category 2, temporarily safe. Tasks requiring genuine dexterity, such as irregular materials, real-time improvisation. Robots still fall apart on this. Bayer & Company puts jobs in this category safe for another 5 to 10 years. 5 to 10 years isn't forever, but it's time to move. Category 3, the people who actually benefit. And this will surprise you. Here's what almost no one in this debate is saying. American factories can't find workers. In August 2025, there were 409,000 unfilled manufacturing job openings in the US. 26% of the current US manufacturing workforce is 55 or older. 3.9 million workers approaching retirement. That wave hits its peak within the next decade. In this environment, robots aren't stealing jobs that exist. They are filling jobs that are already vacant first and creating new ones above them. Robot deployment technicians, maintenance engineers, integration supervisors, roles that barely existed 5 years ago, already clearing $70,000 to $90,000 in the US market. The people who get hurt are the ones who wait to be displayed. The people who benefit are the ones who get ahead of it. Thousands of Walker S2 units are already deployed in real factories. Global humanoid robots orders are tracking towards tens of billions in commitments over the next 5 years. This isn't a prototype story anymore. It's an infrastructure story. And the cost curves only go one direction. The factory owners who bought in 2025 aren't paying for today's efficiency. They are buying their position in a race that has already started. Here's what I want to know from you. As this 5 to 10 year window closes, what specific skills are you building today to make sure we will be indispensable tomorrow? Drop your answer below. I read everyone. If this video got you thinking, I've got 2 videos on this channel. Both are linked on screen right now, worth your time. And if you're new here, and if this video is the kind of content you want more, hit subscribe and turn the bell. I will see you next week.